Kirchhoff's voltage law, or KVL, states that the sum of all voltages around any closed loop equals zero. In other words, if you start at any point in a circuit and travel around a complete loop back to the same point, the voltage rises must equal the voltage drops. We write this as the summation of V around a loop equals zero. Convention. When we travel through a source from minus to plus, that's a voltage rise, so we write it as positive. When we travel through a resistor in the direction of current, that's a voltage drop, so we write it as negative. Let's apply KVL to a simple series circuit. We have a 24-volt source connected to 3 resistors, 3 ohms, 5 ohms, and 4 ohms, all in series. Since they're in series, the same current I flows through all of them. Applying KVL around the loop. 24 minus 3I minus 5I minus 4I equals 0. Combining. 24 minus 12I equals 0. So I equals 24 over 12, which is 2 amperes. Now we can find each voltage. V1 equals I times 3, which is 6 volts. V2 equals I times 5, which is 10 volts. V3 equals I times 4, which is 8 volts. Let's verify. 6 plus 10 plus 8 equals 24. KVL checks out. Kirchhoff's current law, or KCL, states that the sum of all currents entering a node equals the sum of all currents leaving that node. Equivalently, the algebraic sum of all currents at a node is 0. We write this as the summation of I at a node equals 0. Convention. Currents entering the node are positive, currents leaving the node are negative. Or you can use the opposite convention as long as you're consistent. KCL is based on conservation of charge. Charge cannot accumulate at a node, so whatever flows in must flow out. Let's apply KCL to a circuit with 4 nodes, A, B, C, and D. At node A, we have 5 currents meeting. Using our convention, entering is positive, leaving is negative. Currents I2 and I5 enter the node. Currents I1 and I4 leave the node. Writing KCL at node A. Plus I2 plus I5 minus I1 minus I4 equals 0. We can rearrange this as I1 plus I4 equals I2 plus I5. In words, total current in equals total current out. You can write KCL at every node in the circuit. For node D, with known values, 2 amperes minus 4 amperes plus 2 amperes equals 0. The sum is indeed 0, confirming KCL. Let's recap Kirchhoff's 2 laws. KVL says the sum of voltages around any closed loop is 0. Voltage rises equal voltage drops. KCL says the sum of currents at any node is 0. Currents entering equal currents leaving. Together with Ohm's law, these 2 laws give us everything we need to analyze any linear circuit. In the next video, we'll explore voltage and current dividers in more detail.